very much.
Thank you. Well, very good afternoon, Mr. President and distinguished guests. And Sir James, thank you for being with us and spend the next 20 minutes on this fireside chat. So what we're going to do is that I'm going to just ask you a few general questions while wait for students to come forward and be prepared for questions, because I understand that you would like to really engage the students and hear what is in their mind and inspire them. So students, please don't wait for all my questions, all right? Please go ahead and take up the mic, and as soon as our conversation reach a point where I see you're ready to ask a question, I will pause, okay? All right, you can come right up to the mic right now if you want to, okay?
You look complicated.
Complicated? Well, engineers are complicated, no? No, I'm an architect, unfortunately, so I tend to be complicated.
Okay, simplify them.
Yes. All right, let us start with this. You said earlier that, I think in your speech, if I recall, the SUTD and Dyson shared the belief in challenging convention and engineering, as well as engineering a better future. Now, you have invented numerous iconic products, from the ball barrel in 1974 to reimagining how cordless vacuum works, the bladeless fans, and of course, the Dyson supersonic hair dryers. What has fueled your courage and creativity to achieve these breakthroughs? So, yeah, I'd like to hear your views.
Well, it's a good question. I think all engineers are curious, and I think almost all engineers want to invent things, which is great. And when all engineers, all of you, when you look at things, you wonder how they work, and then you start to wonder how they could work better. So I think wanting to change things, invent things, improve things is a very natural result of being an engineer. So I'm no different to anybody else. I don't actually know why I wanted to also be a manufacturer and a marketeer and develop technology and do the whole thing. I don't know what made me want to do that. It was probably a pretty stupid decision, but I'm glad I did it. But it wasn't easy. But I think I wanted total control. I didn't want anyone else to tell me what to invent, and I didn't want anyone else to make it. I wanted to do the whole process.
Yeah, I guess that's always a kind of expected outcome, because as you innovate, you want to see it realized in the right way. Therefore, the manufacturing route is really unavoidable, isn't it?
Yes, I mean, I did, at various stages, I've tried to convince other manufacturers to make my designs. And in almost every case, it failed for various reasons. So to some degree, I started manufacturing out of necessity. But actually, I enjoy it. I find it's a very tricky process, and there are problems every day, and new problems, all sorts of difficult problems. But it's very rewarding to actually see something you've designed going down a production line, and even working on the production line is a very creative thing to do. A lot of people think that manufacturing is not creative, but it is. It really is. You are literally creating.
Yeah, tell us a bit more about that joy. I mean, you're right. I mean, when people think about manufacturing, it's dirty, it is dangerous. But I was told that you're very hands-on. You literally kind of watch every process and every step leading to define the product.
Manufacturing is actually a very intellectual process. It's highly complicated, and everything can go wrong, and indeed does a lot of the time. So it's again, for an engineer, it's overcoming problems, learning how to make things, more economically. And you know, tomorrow it's got to be done differently than it was today. I think the old method won't work. So there's nothing wrong in an engineer going into production and becoming a maker and not just a creator. Well, you are a creator. You're making something, literally.
Yeah. So would that be the advice for all our engineering students to model after your life experience?
Well, as an engineer, I always enjoyed making prototypes. I mean, now everybody uses SLS.
I heard about the
Rapid
4,000.
prototyping. For me, that's a bit of a shame, because I think machining something and making things by hand is a creative process. And there's something about making a prototype actually yourself, physically making it yourself, which a lot of our engineers do, by the way.
Yeah.
You really understand what you're doing, and it gives you ideas on how to improve it while you're actually making it. You wouldn't think that, but actually you do.
Yeah. I was told a story, I don't know whether it's true, that you have products that go through like 4,000 prototypes.
It's more than that, actually.
It's more than that.
No, to get my cyclonic system right, it took 5,127 prototypes.
Oh my goodness.
And we're still doing that kind of thing. And of course, it's easier now because you have computational fluid dynamics and all sorts of things to help you. But nevertheless, we still develop a lot of products empirically.
All right. Do we have students who are ready with your question? Yes. Yes, come forward and identify yourself. And all right.
Hi, Sir James Dyson. I'm Elvin from Engineering Product Development, a Year 2 student. So I have a question is that, how do you personally distinguish between a failure that is worth pushing through and a failure that signals a need for a change in direction? That's my question.
Good question.
Yeah, that's a very good question. The motto really is to never give up, but at the same time recognize that you don't know the answer when you start, and you don't know it's going to work, but you have an idea. And often we start thinking of the wrong idea. I mean, often there's an obvious solution, an historical solution to something. But if you start the wrong way, thinking of a completely different way of doing it, which I like doing because I just want to be different, don't want to do what everybody else does, and that sets you on the path. And sometimes you'll get there, and sometimes you won't. Failure, as I said in my speech, is simply goes along with experimentation. You won't create something new or different or better if you don't experiment. But most experiments fail. I mean, I always say that my life is one of failure. You know, all day long, we fail. But if we just keep going and keep going and keep going, we usually succeed. Not always. It's not a given. Sorry, that might sound rather depressing. But you as engineers completely understand that. You won't always succeed. But that doesn't mean you shouldn't try.
I mean, Sir James, just building on that question, you roll out a huge number of successful products. From the eyes of the consumer, from the market, all we see is success. Tell us one story of failure.
I was trying to hide the failures.
Is that one of the lessons that we should learn? Hide our failures?
I mean, things fail not just because, I mean, you can do a really good product and it can fail commercially. So even though you've at last made it work and it's going down the production line and it's wonderful, it doesn't mean it's going to work commercially. It doesn't mean it's going to make money. It's all a big risk.
Yeah.
But unless we take these risks, unless we try to take these big leaps, we'll fail anyway. But you just have to accept failure and bounce back from it.
Yeah, but sometimes failure don't come in the form of outright failure. It comes first as a kind of successful rollout of a product. But only months later, then you start to realize that this is not quite right. Have you actually experienced that? That you have to change the product midstream or something like that?
Well, of course, but I won't tell you about that. But yes, no, I mean, it is a life of continuous improvement. And engineers, I mean, a lot of finance men hate engineers because they're always wanting to change things. They always know there's an improvement.
Right.
And they want them to stop and get the product out and get it making money. But it's a wonderful characteristic of an engineer that they want to go on and on and on improving it.
Right.
And it is, of course, true that when we finished a product and it's going into production, we already know what the next one is and probably the one after that. I hesitate to say it, a bit like the fashion industry with its seasons and so on. But it is like that for us, and thank goodness it is. We've got a future ahead of us.
Yeah, great. All right. Second question? Yes, come forward.
Hi, my name is Jun Lin. I'm a freshman in SUTD. And you know how AI is the trend right now. And you've recently said that AI can pretend to be creative, but it can never do the unexpected. As we use more generative AI tools in engineering, are you worried that like engineers, young engineers such as myself, might lose the ability to derive solutions, or should we embrace AI in our work?
Well, I'm 78, and I'm probably the worst person to ask that sort of question. But you know much more about AI than I do. But my view of it is that it sounds to sort of denigrate to call it a tool, but it is a wonderful tool. But it can't replace the creative engineer or the inventor or the designer, for that matter. You can use it. And I'm sure a lot of people will use it for design and to develop things. But I think in future, it puts a much greater emphasis on creativity. It almost does the opposite of what you might think. So I think what will become really valuable is the engineer or the designer engineer who can really be creative and do something different and unexpected. And I think that's what the public wants from products and devices. They want something they hadn't expected, something that shocks them slightly and is different and better. So I'm optimistic in the sense that if you want to be creative and do something different, that's a skill you have that AI doesn't have.
Yeah. So perhaps AI doesn't have it today. I mean, you say you're 78, but you've gone through the digital revolution that saw us move from paper to computers. And that clearly has an impact on design. And looking forward, do you think AI will reach a point that gives us a certain kind of breakthrough, especially in creativity, that we can't imagine today?
Well, I don't think it will. I think it can only reproduce combinations of something. I don't think it can do something unexpected, something shocking. I mean, I don't say shocking's got rather bad connotations, but I do think that consumers want to be surprised and even shocked by something. And I don't think AI can do that. I may be wrong. I'm 78, and it's not really my problem, but I don't think it can.
Would you like to consider commissioning a competition between the traditional designer of your team versus a DAI team from SUTD?
I don't think they like that idea. I don't think AI needs encouragement. It's got enough encouragement as it is.
Okay. So no resistance to the use of AI as a very powerful tool, but you do feel that creativity is more important ultimately for the training of an engineer.
And I think AI will get it wrong. Do you want to drive your car over a bridge that's only designed by AI? Maybe you do, I don't know. But I think humans are important and will always be important.
So let's talk about the creativity, because I think earlier we had this conversation back in the waiting room. How do you think creativity can be trained, especially in engineering or engineers?
Well, that's a very good question. I think it just needs to be encouraged. I mean, when I see 8 to 10-year-olds in schools creating things, they're uninhibited and they're creating. But somehow academic life at school and maybe even university inhibits it. And I just think we need to allow people to be different, to think creatively. I mean, it's very interesting because almost every job after you leave school requires you to create something, do something differently, whatever walk of life you're in, because life's changing all the time and problems are changing all the time. But we don't teach that enough in primary, secondary, or tertiary education. We try to teach people the rules, but the rules are changing. And in life, you'll be dealing with problems, and problems require creativity to overcome them. So I think we could do better in schools, and possibly better in universities, but I'm sure you do very well here on creativity. But most universities don't, I think.
How do you learn creativity yourself?
How did I learn it?
Yes, when you were young, I presume.
Yeah, I mean, unfortunately, when I was at school, we didn't have design and technology. That wasn't a subject. And my father was a classics master at school, Latin, Greek, and ancient history. And my brother was a classics scholar. And I think I wanted to be different. I mean, I did classics. I did Latin, Greek, and ancient history at school. But I also did art. And although engineering was known about when I was young, back in the 60s, design wasn't. It wasn't a subject. I mean, nobody knew about design. It was very much a post-Second World War society, whereas, just to have a refrigerator or a car or something was terrific, without worrying about whether it was well designed. So I went to art school to paint, to be a painter. And then I discovered design. And I became a designer, and then I discovered engineering and became an engineer. So I had a strange journey to be where I am. But I don't know where the creativity came from at all, except a desire to paint, to make my own paintings, and then to do my own designs, and then to do my own technology.
Would you
a control freak, maybe.
Would you advocate such an experience for SUTD engineers?
Sorry, would I?
Would you advocate such an unusual journey?
Yeah. Well, yes. You don't have to do what you learned at university or what you learned at school. You can do something completely different and be all the richer for it because you've had different experiences. I can't actually tell you what use my Latin, Greek, and ancient history is, but maybe it's training the mind. Training the mind is very important.
Well, just for the audience information, I think SUTD has been talking about this Design Innovator Venture Experience, DIVE. I think that's very much aligned with your thought, which is offering an alternative education, alternative way of learning and seeing things. All right. Do we have another question from students? All right. Come forward.
Hi, Sir James Dyson. My name is Kishore. I'm a Term 1 student. Just now you were mentioning that you went through design first and then you did engineering afterwards. So my question is, was there a defining moment when you were transitioning from design to engineering in your early career that shaped your approach to current engineering knowledge? And how would that apply to us engineering students?
Yes, that's an interesting question. When I was educated, design and engineering weren't mixed. There were designers who made things look good after an engineer developed a product, and there were engineers who weren't involved in the final look of the product or the form of the product. So they were two separate professions. And I think I was fairly early on in being someone who wanted to be both a designer and an engineer. So I've slightly forgotten your question. What was the second part of your question? Can you remember what it was?
I'm afraid not. No, we let him ask.
Yes, sorry, I know what I wanted to say. Sorry, it's old age. I think the defining moment was when I realized that to develop something, you don't come up with a brilliant idea and you have the solution there through a sort of flash of brilliance or lying in the bath and thinking of it. It comes through building prototype after prototype. And so you have an idea to start with, which is probably completely wrong, and you make one change at a time. And then you see what difference that change made. And then you make one other change, one change at a time. So each time you're learning whether your change made a difference or not, or what difference it made, or whether it made it worse. So it's that the process of, it sounds tedious, but actually it's really, really fascinating. This iterative process of building, as I said earlier, 5,127 prototypes. I mean, that sounds boring and it sounds tedious. It was actually the exact opposite. It was very, very exciting. So the defining moment that you were talking about, it was that you don't have to be brilliant. You don't even have to be that intelligent. You just have to be painstaking and curious about the effect that each change had on your prototype.
All right. Maybe we have time for one more question. All right.
Hi, Sir James Dyson. I'm a freshman here in SUTD. So my question was, if you were to start your career today in 2025 with all the new technology and everything, where would you focus most of your creative energy into?
Well, what I'm doing, exactly the same thing. I mean, I think to be successful in the world, we have to make things. And if we're going to make things, we've got to make things the world hasn't got and that people want, something that improves life, improves what it does, uses less energy, less materials, whatever it is. So I'd go on doing exactly the same thing because that's who I am, that's what I want to be, and I suspect that's what a lot of you want to do. So I wouldn't, of course I'd do it differently because the world's changed a bit, but in essence, that's what I would do, and that's what I would advise you to do if you're interested in that sort of thing.
Thank you so much. I'm also here to ask a question on behalf of my friend Alex, who's an exchange student here at SUTD. So his question was, as you look back on your life, are you proudest of your final products or your processes that got to those products, or the creation of infrastructure that ensure that innovation at Dyson will continue?
I have no doubt that innovation in Dyson will continue because there are lots of very bright people there who are having much cleverer ideas than I ever had. Really, it's like having children. You don't have a favorite, but they each have their own characteristic and did something different at the time. So I'm afraid I like them all. And I think most people are like that.
Thank you so much, sir. Thank you.
Thank you. Thank you. Well, Sir James, thank you again for spending time with us and our students.
Thank you for the honor.
Yes.
And it's very good to meet you all. And thank you for all those wonderful questions. But above all, good luck and be different and be bold. Thank you very much.